Welcome to week 7. And no, the title of this segment is not because of the fact that we are nearing the end of the course, but because of something else. So recall from week number 3, our try except block. This whole week is about debugging, troubleshooting, and testing buggy programs. So if you will recall from week number 3, we had this buggy divide function that divided two numbers, x into y, right? And at first we implemented it kind of with a silly approach, and we didn't acknowledge that y could be 0, and that would result in a runtime error, which we now handled with an exception. And I hope you remember that the try except block helps us handle errors that are of runtime nature. It would not help us with something like a syntax error where your program wouldn't even begin to execute. It also would not help you much with logical errors where program just behaves completely incorrectly. But in this case, what we did, if you remember, we tried to divide x by y. We told the computer, if you can do it, go ahead and do it. Otherwise, don't generate an error, but give me some other output, right? That's what the except block does here. It simply prints you can't divide by 0. I hope you know that, right? And it returns none as opposed to the result. And this was the execution of the program. We executed it twice. First, we divided 6 by 3, which is there's no issue there. The result is 2.0. But then we attempted to divide 7 by 0, and where we would have caused a runtime error, the exception was raised and caught with this except block, and we printed, you cannot divide by 0. So this was the try except block that we knew. That was all to it. Well, there is a bit more to it than that, and you will notice it's kind of a thing. There is always more, always more. Here, because in this week we will be debugging a lot, I wanted to introduce, to kind of complete the try except block structure by introducing two other clauses that are often present in the entire try except kind of series of clauses and the entire block. First of all, we can catch not one, but multiple exceptions of different kind in order to more granularly fine-tune our error handling and have our program behave in different ways. Because I hope you understand that depending on what kind of error was caused. So up until this point, it's like if any error is caused, whatever the runtime error is, our except block behaved always in the same way, and it would be hard to notice what the issue is in big enough program, right? Now, if you can, as we will see shortly, you can catch multiple exceptions, and depending on what the error was, your program can behave differently. In addition to that, the try except block also has the else clause, but that is optional. It doesn't have to be present. If it is present, it must follow all of the except clauses. So you cannot have try except, then else, then except, then else. So else comes after all the excepts, and you can have multiple excepts, as we will see shortly once again. And it is executed if and only if the try clause did not raise any exception. And finally, that's why the segment is called that, finally, there is the finally clause, and it is also optional. It does not need to be present. If it is present, it must follow all of the except clauses and the optional else clause if that is present. So you don't have to have else, you could have try except finally. You don't have to have finally, you can have try except else. But you can also have try except, else finally. Finally, it defines what's called all the cleanup actions that must be executed no matter what. So no matter what exceptions were raised or not raised, handled or not handled, finally clause will execute last and always. And yeah, as I said, it executes as the last task before the try except block completely exits and execution returns normally. And it is always executing at the end, as I already mentioned. So the best way to visualize this is by way of example. Now I will switch over to my lab machine and we will open the file try_except_else_finally.py, and that's quite a mouthful. I encourage you to open it and follow along, and you will find that file, of course, as always, in your downloaded course materials. Let's jump there now. Great. So the comments say, what this does, it demonstrates catching multiple exceptions and using the else and the finally clauses in the try except code block. So my comments as usual, main function as usual, and here is our complete try except else finally block. Let's see what this does. And I know in order to demonstrate this, I will introduce a few concepts. I do not expect you to remember or understand or memorize any of this. You will not be tested on particular statements or how this behaves or why. This is just for the sake of example. And I tell you exactly what each of these things does. And no, we have not covered them before. So here, first statement is fp gets open, and then we have file txt in R. Now, what does all this mean? Now, what it does, it opens a file.txt, in the same directory where the current Python module executes. And it tries to open it with read-only privilege. That's what this R is for. And if you're wondering why did I call this FP, it's not really descriptive. Well, actually, for this particular purpose, it is. It's kind of a convention. FP stands for file pointer. And we will not go into too much detail how pointers behave. It is not needed for the sake of this example. Now, next line says a line gets fp.readLine. Now, you probably already at this point know readLine in the syntax, it means we are invoking a method of the file pointer. And what this does, it reads the first line from that file. Next, we have already seen what this does. It tries to convert that data, whatever that is, basically the line we just read, into an integer, because we have this int call to cast as an integer, and all this line.strip does, it clears all the unnecessary characters from the beginning and end of the line. Now we have two except statements, and they try to catch different type of a runtime error. First, we will accept what's called an OS error. OS stands for operating system, and we will call it locally as OS_error, and it will print it in this kind of format. And again, we will not go into like why this is, what it does, just follow along. And then we will accept what we should be familiar with at this point, which is called a value error. And here, as we have seen before, it says we could not convert that read data into an integer. Now remember, the else clause, it executes if and only if the exception is no exception is raised in the try clause. So if either this is raised and caught, and either or this is raised and caught, the else block will not execute. Let's see what it contains. This else block, if no exception has occurred, now we know that we successfully converted that particular particular value from the file into an integer. And what we will finally do in that case, we will close the file pointer, fp.close. Close is another method. And remember, what finally does, it executes no matter what. And all we will do here is we will print exiting program, right? Let's try to run this particular module. We will invoke it with Python try, and let's see what happens. And I hope you saw what was going to happen. First, it says OS error, so it's an operating system error. No such file or directory, file1.txt. That is odd, but we were hoping to open the file.txt, but of course, as you can see here, we fat-fingered it, and there is an additional character. File1.txt does not exist. So we need to correct that. I will simply delete this 1. We will save the file, and here I have it also opened, so we see the contents of this file. It contains a single line, hello world. Again, I hope you can see what's going to happen next. So there will be no exception here. We'll be able to read that line, but I hope what's going to happen, you know what's going to happen when we try to convert that line into an integer. Let's try that now. I will leave this here for reference, and we will simply try invoking the same file again. Now we have a different error. Error could not convert data to integer. So we are handling two different types of errors, and we behave in different ways. In this easy example, we simply print different things, but in more complex programs, you could actually do something very powerful and very different. Now remember what we said about the finally clause. It always executes, no matter what, if the exception is raised, not raised, and notice, after the error was printed in each case, we do print what is contained in the finally clause, exiting program. We have a different type of error, exiting program, right? Okay, let's correct that. So we know the program is expecting an integer, but this is not an integer. Let's put here 1, 2, 3, 4, 5. Now that is an integer, right? It could be interpreted as integer when we cast it to data type int. So we know this exception will not be raised and caught because the file is now named properly. We know this exception should not be raised and caught because now it will be reading and casting what is actually in the form of an integer. Now, because no exception was raised and caught here, right, I hope you can see that the else clause will now execute. And what we should see printed is now we have successfully converted those data. Again, I'm going to leave this output here for reference, and let's try executing this once again. Excellent. Now it says no error was caught, and no error was raised and therefore caught, and we see that the else clause now executes, and it says it has successfully read and converted data 1, 2, 3, 4, 5 into an integer. And once again, the finally clause executes. Okay, let's just recap one more time. So first, we can catch multiple exceptions to serve different purposes, again, depending on what the error is. We don't have to, but can have the else clause. If we do, it must follow all the except clauses, and it executes if and only if no exception was raised. We can, but don't have to have the finally clause. It must follow everything else, all the except clauses, all the else clause if it is there, and it must contain, and it always contains, tasks that usually must be executed to clean up the state of your program. I hope now it is a bit more clear, and now we have seen the entire try except logic in Python. There's not much more to it, and I thought we would save this for this week, because this week is again about debugging and troubleshooting, and in bigger programs you constantly use try except logic to catch any potential runtime errors and make your program kind of handle that and behave in different way.